Hello, today we're going to be starting with some geometry. We are done for the most part with the algebra textbooks and we will be jumping right into geometry. First chapter is number 2 and 2.1 is titled Patterns and Inductive Reasoning. The learning target for today is to use inductive reasoning to make conjectures. And the definition for inductive reasoning I have written out right here is it is reasoning that is based on patterns you observe. So if you're looking at some sort of situation between a sequence of objects or numbers or anything else and you notice a pattern between them, you are practicing inductive reasoning. Here's one example of how you can use this. Let's say we have a list of numbers that are 3, 9, 27, and 81. You may notice that a pattern between them is that to go from one number to the next, all you do is multiply by 3. 3 times 3 is 9. The same exact thing can be happened from 9 to 27. You multiply by 3. And then from 27 down to 81, you multiply by 3. So if I asked you to find the next 3 numbers in the sequence, or next 2 numbers, the inductive reasoning you would use to find the next 2 would be to take this and multiply it by 3, and you would get the number 243. Then in order to find the second number after that, you do the exact same pattern, multiply by 3, and you find the next number to be 729. Okay, another one could be used to find shapes. Let's say you start out with a triangle, then your next shape is a square, then the next shape is a pentagon. Okay? The pattern you pick up between from one shape to the next is that this is 3 sides, this is 4 sides, and this is 5 sides. So all you do to go from one to the next is you add one side. So to go from the pentagon to the next shape, all you do is you add one side, and you get a hexagon. Then to go to the next one, you add another side. Okay, so this is using inductive reasoning, finding patterns between each object, each number, and you could use this to find the next numbers or objects in each sequence. Okay, the next thing I want to talk about is a conjecture. And a conjecture is a conclusion that you reach when using inductive reasoning. Looking back at the last example, the conjecture that we found in the numbers is that you multiply each of the last numbers by 3 in order to get the next one. In the shapes, you add one side length from the previous one in order to get to the next shape. That is a conjecture, and that is something that you can conclude when you use your inductive reasoning. So let's say, for example, we have a circle with one diameter, and this diameter divides the circle into 2 regions. Then you have a few more circles after that with 2 diameters, and it divides it into 4 regions. Then the one after that is 3 diameters, dividing it into 6 regions. Then the very last circle is 4 diameters, dividing it into 8 regions. So what conjecture can you make about the number of regions for 20 diameters? Okay, so you may notice that to go from 1 diameter to a region, you multiply by 2. To go from 2 diameters to 4 regions, you multiply by 2. The same happens from 3 to 6 and from 4 to 8. So however many diameters there are, you multiply by 2 to get the regions. So for this example, we have 20 diameters, multiply that by 2, and that gives us 40 regions. Okay? Alright, and here's the last thing that I want to talk about. Finding counterexamples. Now, a counterexample is something that you can show to prove that the conjecture is wrong. If you come to a conclusion and you may find that there is an instance where it doesn't always work, a counterexample is an instance that points that out. So let's say we have a conjecture that if we have the name of the month that starts with the letter J, it is a summer month. So obviously all of the J's, we have June, that is a summer month. We have July, and that is a summer month. But there is another month, January, that starts with a J, and it is in the winter. So your counterexample is January. It's a winter month that starts with a J. So not every month that starts with a J is a summer month. And the very last one is that if you multiply a number by 3, its product is divisible by 6. So if we just go through a list of numbers, let's try 3 times 2. That is equal 6. 6 is divisible by 6, so this one does not work. Let's try 4. 3 times 4 is equal to 12. 12 is divisible by 6, so that one doesn't work. The next one I can think of is, let's do 5. 3 times 5 is 15. 15 is not divisible by 6, so this is a counter example. There may be more than one counter example that is an answer. I think there is a number that's like in the thousands, of course, or in fact 3 times 3 is 9, and that is not evenly divisible by 6, so even 9 works. But this is just one counter example of why the conclusion or the conjecture is false. Okay, so before we get started on the work, I'm going to talk to you guys about how we're going to take the learning targets and convert them back into questions, and we're going to be doing that with every single section before I give you the work for the day. Okay, thank you very much.